Pleased to introduce Dr. Lei Shirley Xu. She will bring a valuable perspective from food industry. Dr. Xu currently serves as the principal scientist, the protein expert, and innovation project manager at Nestlé Health Science in the United States. Prior to joining Nestlé, she held different roles in the food industry, including positions at InnoHope and Motif. She earned her PhD degree in food science and technology from Purdue University. Today, she is presenting a topic on alternative protein unlocked, formulation, processing, and consumer demands. Dr. Xu, the stage is yours.
Thank you, Dr. Zhang, for your introduction. It's my great honor to have the invitation from CAFS. And just for the audience, I really appreciate you guys' time at Friday night. Instead of have a happy hour or TV movie, stay with us until now after 1 hour. I really appreciate. And also, thank you for people who join globally. And we appreciate your spending your time here. And I hope you guys also enjoy as much as me from Professor Zhao, Professor Rao about their presentation. I think they gave a really great presentation in terms of from scientific academia, industry, academia point, how to further improve the ingredients and how to predict the model, using model to predict the gelling. So it means a lot to industry. So in my presentation, I'll briefly use my experience to trying to interpretate how to adapt alternative protein for the food industry. So this slide is briefly about me, my background. So I came across actually with Professor Zhao in Wisconsin. So I was also studying the dairy protein. And then I finished my PhD at Purdue, working on more kind of food processing, how to use cold plasma, attending a lot of nuclear science class as a food scientist. So quite learned quite a little bit like information outside of the food science area. And then I have been working in different type of companies. So including like working on more kind of research, working on food, retort process, precision fermentation. So right now I'm currently the principal scientist at Nestlé Health Science, working on specifically for food supplements, how to tailor the protein into a broader application, including medical food, supplements, oral nutrition supplements, etc. Um, Before we jump into how to adapt alternative proteins into food industry, I would like to come up a question like for you guys to think why we want to use alternative protein. This is quite interesting and important for us to kind of think and revisit. Most of people will know that alternative protein is quite good sometimes in terms of nutrition, sustainability. There are millions of like publications to indicate LCA, how the carbon footprint means gonna be improved from dairy proteins. Of course, the market needs, but for the industry, the question will also come to us. Besides the technology revolution, including the ingredient innovation, the processing technology, for the consumer, it's also quite important to convey them why they switch eating meat burgers to eat a plant-based burger, drinking dairy milk to plant-based milk. So this is quite important when you communicate with consumers, understand their current pain point before you start to develop your product. And the second one question I would like to invite everyone to think about, what are the alternative proteins? What are the options for us? So it's quite famous for us to know, okay, could be non-dairy. So as we know, we all very familiar with plant protein, pea, soy protein, right? What else? So we have yeast protein. So you've been very, very famous about like you're familiar with the nutritional yeast. The yeast protein right now can develop to be extract with to a more than 85% protein in a powder format, and with very good nutrition and also functionality. And also there's a fungi, there's microalgae, and there's of course precision fermentation. So all those products made with these proteins are commercially available on the market. So if you Google it, check your Amazon, check your Taobao, check everywhere, and go to maybe Costco, Whole Foods, you are able to find the protein made with all these alternative proteins. So, how to adapt this protein into a finished product? I'll share a little bit my thoughts today into three parts. The first part is formulation, followed by processing and consumer demand. So, just another question to ask, how to twist this alternative protein from a formulation standpoint? So, for a food overall, we always know that taste is the king. So sensory. And of course, we have heard from Professor Joe, Professor Rao, Professor Zhao about the sensory defect and the techno functionality about the jelly impact. Sometimes jelly is good, sometimes might be not pleasant for beverage. For the sensory part, like the pea protein, if you have a different process, it will taste very different. I don't have to name all the pea protein dairy part on the market. If you grab it, if you taste it, you can see a significant note. Maybe we call like beanie, we call it like some other protein maybe have astringency. So sensory profile is quite important for us to be considered when you adapt alternative protein into products. And the next I want to mention primarily is the nutrition. So maybe later on I'll mention more about how to tailor what are the difference between those proteins in terms of nutrition. Functionality. So we are highly depends on the industry, which is the ingredient, how they can further purify the plant protein, how they can modify the protein in order to improve the protein functionality. In the meantime, I invite everyone to also think about what are the major functionality of the protein in a food matrix. There's a solubility, foamability, gelability, and they're all diverse. Sometimes you may want a protein to be functional. Sometimes you may do not want a protein to be super functional. So it really depends on the food product type. For example, if you apply a pea protein or soy protein into your beverage, when you adapt into like 3% to mimic a dairy milk, yeah, tastes okay. It can be suspended. But I invite you to think about if you go to Costco and buy organic product, which are very famous in the plant-based and also from Nestle Health Science. And if you just keep dumping this powder into water, and you can see the viscosity increase. So that means when it comes to another product like a 30 grams protein, which you can see from Costco, why all those protein or all those 30 grams shake become so different in terms of viscosity, in terms of mouthfeel. So that's the major difference when you select the protein as a product developer, as a consumer. The viscosity may be very different in terms when you adapt this into after UHT process. And also the regulation. So I have mentioned a lot of plant protein. How about the other alternative protein as I mentioned, especially for the precision fermented protein? And right now you can find it from online, from the store. There are very famous, very leading company leading in this area for producing the dairy protein without the cow using precision fermentation. So their big challenge is that the regulatory part. They passed the FDA, however, they have a hard time in the Europe. So that's what another point for the industry, like the regulatory is a very big pain point, both for the end user and especially for the manufacturer of those ingredients to scale up and commercialize. Then I'll give a very basic example about using plant protein, which are very familiar. So for the dairy cow, we are very familiar. It's high in protein, high in calcium. But think about when consumer, instead of buying a jar of dairy milk, now you're gonna twist this with soy milk, pea milk, chickpea milk. What are the major difference in terms of nutrition? huge difference because all their amino acid profile are very different, and a majority of the plant protein are short of cysteine, methionine. That means if you consume pea or soy milk, it won't meet all your PDCAS requirements or amino acid requirements as your daily routine. You have to eat other source of protein to fortify your amino acid source. So that's only one example how the plant protein will be differentiated in terms of nutrition, needless to see all the vitamins and calciums. Another aspect I want to mention is that when we select the protein, we're also facing there's also a lot of opportunities. So as I mentioned, there are challenge and how to mitigate with opportunities. So I will propose in two ways. One is ingredient innovation. So as Professor Rao has mentioned, the scientists, experts are actively working on using advanced technology to further improve the raw ingredients by purify the proteins, by modification, so that can improve the functionality of the proteins. And also they can using different technologies such precision fermentation to produce the protein without a cow. And they can also like extract using microproteins, microalgae proteins to use external source, the other source of protein to enhance the nutrition. So on the below, you can see the different source of picture. There are some like, which is from Nestle. We were making like egg replacement with non-egg proteins, all plant-based. There's also fermented protein traditionally from a brewery beer process, and they are using byproduct and to be add as a combined a blend of barley protein to make combine with other protein to make a PDCAS1 formulation. And also, they are using another like fermentation technology to use pea and rice and combine through a fermentation technology. They can make the taste better and to remove off note of the beanie note from the pea and rice. And another aspect to solve this challenge is the processing technology. Means once you have the protein, how can we twist the protein to be more functional? So very famous one that is you are using extrusion technology or we call texturization technology to blending this protein and apply a high temperature and a cooking temperature extrusion process. You can then make the protein to have a texture to mimic burgers, to mimic puff, etc., or chicken nuggets. And there are also like 3D printing and also fractionation. So all those kind of processing technology can be used to enhance the functionality of the proteins. So we have been talking about the challenge. Now, how to twist the challenge. So I'm going to briefly mention the formulation consideration part. As I mentioned, there will be three angles: formulation, processing, and consumer. So starting from the formulation. Using liquid as an example. So formulation, you have to consider the nutrition aspect, the format. So starting the format, it's going to be liquid or it's going to be meat analog or it's gonna be the other like yogurt. So all those formats will trigger a question. What are the pH? What are the major protein you want to contribute as whether it's a nutrition macro component or it's a functional ingredients or it's a texturization ingredients for the meat burgers. And on top of that, you also have to combine with other proteins, other ingredients like lipids, and how to make a cheese can still melt with plant-based protein. So you need some stabilizer, you need some lipids to mimic this melting process. And for the nutrition, as I mentioned, one important thing is PDCAS. So among all the plant protein, PDCAS is super diverse different. So let me see whether I have it here. So what does it mean about PDCAS? PDCAS is called Protein Digestibility Correct Amino Acid Score. It's really to two components. One is the digestibility of this protein. Another one is amino acid score, which is your really to your amino acid profile, and you want to reach to a PDCAS. So PDCAS 1 is using whey or dairy protein as a reference, and the current consumer currently using PDCAS 1 as a reference to evaluate the quality, nutrition quality of the proteins. So back to the slides I want to mention is that you really want to meet the amino acid profile of current dairy protein as a starting point for majority to in order to say that your protein is really to meet the nutritional of dairy protein. So some of them of the plant-based milk really have a hard time to meet the PCAS1. So I invite you to look at the label of any dairy mimic or dairy analog in the market to check their amino acid profile and see whether it's really PDCAS1. If it is not PDCAS1, if it is not fortified, what is the other amino acid you need to fortify with in your daily routine besides continue drinking 1 jars of meat analog? It won't make your life easier. So don't just increase the amount, also think about the quality of the protein that you are eating. And also for the vitamins, so which is very critical component for us, calcium and minerals, all those components. So using medical food as an example, which I'm currently actively working on Nestle Health Science. So we do have special patients who really need to drink 1 bottle, which 8 ounce of protein shakes to meet all their nutrition requirements. Means you have a calorie amount, you need to have all the vitamin, minerals, fat, carbohydrates in 1 8-ounce bottle, which is super challenging because you also want to keep the enough nutrition, but also you want to keep it as a drinkable and pleasant. So for US, the major top two flavor is vanilla chocolate. So we want to keep this milk chocolate flavor beverage drink as close as milk and still you are enjoy this and you are having maybe 10 times energy than a typical milk. So imagine as a product developer or formulation developer or nutritionist how challenging it is. And think about a typical 10% of milk protein concentrate versus a 10% of pea protein concentrate. Their viscosity will be super different. As Professor Rao has mentioned, that their viscosity will be different because in terms of nature, because of particle size, because the solubility, and also Professor Zhao has mentioned about gelling property. When you keep increasing those protein proportionally, their gelling property will be huge different. So we appreciate Professor Zhao that developed this toolbox using AI so we can also adapt into our like a real life application. And quality. One thing I'm afraid I have to mention this is that for majority of the plant protein, especially pea, you might have a concern of cadmium. And for the rice protein, you might have a concern of the lead. Means not all the plant protein will be perfect in terms of quality, for like contamination, in terms consistency, because even you buy the pea protein produced from the summer will be different from the winter, or from China will be different from Canada. And from canola protein will be diverse protein from you get the pea from US. So that's why the quality in terms of contaminant, especially this will be super important for like medical patients, for patient with different age group. If your age group from age 3 months below, we have a super higher standard in terms of quality for the contaminant, like for baby food, Gerber, our quality requirements super restrict. So especially this challenge of the vendor, like as a pea protein vendor, you really have to make sure your pea protein produced from each batch consistently have a low contaminant. And the chlorate, which when you produce pea protein using the water, the chlorate could be really high if you're not control your water. So it's not control your pea production, it's more about the water. So imagine that, apply this methodology into across plant protein productions. So right now people are really leaning towards into biomass protein. They want to explore, okay, without seasonal change, without the geography impact, biomass protein can also provide a good low contaminant protein, which offers new opportunity to increase the quality. So another thing is for the consumer market. So I have to mention that I wish I can show a lot of example, but I'm trying to avoid to show the pictures of the brands or the product specifically, more focus on the consideration overall high level information. For the consumer, if you're talking about pea, soy, they might not focus too much about the proteins. And if you're talking about sustainability, okay, let's see, I'm selling you $2 a pea milk, and in the cow milk, it's like $1.7. Which one you will prefer? But if you pay this 30 cents, you're gonna save the world, save the cow, make their life easier, save a lot carbon footprint. Some of the consumer, they are willing to pay this $30. Unfortunately, there's a big portion they are not convinced just because to save the world carbon footprint in order to pay extra high dollars. It might be organic. That's a story you want to convey. So how to convey the story when you switch the product like a source, the protein source into your product from the traditional animal protein. This is the bigger storytelling which the current marketing is facing. As I mentioned, when you talk with consumer, taste is the king. We have to make sure the taste good and you enjoy this product as much as animal sourced protein as a number one rule before you want to communicate with the sustainability part. And also clean label. So what does it mean, as most of the expert in this audience know, that clean label means you want to have a more shorter ingredients or have a shorter name of your ingredients, or friendly, consumer friendly. They can easily recognize source of the source of the proteins or source of the sugars or fats, lipids. They can put a puree instead of fruits concentrate. They can put a honey powder instead of the sugar or lactose, you know. So those are the tricks for clean label when we develop those ingredients. There are also tricks that if since the label is labeled in the order of the ingredient quantity for the most of the country in this order, so they prioritize the most label friendly ingredients as the predominant ingredients. So if you have 50% dairy protein and then 49% of pea, your dairy protein will be on the first ingredient protein source. So that's the tricks current industry. I invite you when you consume your product to look at your label, look at the order of the label. You will find what other tricks in this alternative protein product world they are trying to mitigate with people, consumer, like you are paying a higher price and but you are consume less premium proteins. And cost, as a manufacturer or vendor product or like ingredients provider, cost is super important, especially with the chaos supply chain and also the tariff currently in between the countries. So they are facing a lot of challenge to manage the cost with alternative proteins. If you look at the dairy protein price change, It's huge. Currently, caseinate become increase. Whey protein last year super high, and now maybe the manufacturer have to switch the caseinate to skim milk powder in order to avoid this continue paying high protein cost. Now, another option is using plant-based protein. So they can reduce the price maybe from $12 to $6 if you switch to pea protein. And the pea protein, if it is still high, if you can switch to soy protein. Soy protein is even cheaper than pea protein. So you name it. Cost is one of another important factor when manufacturer to be considered. So let's invite also as an ingredient provider. If you are thinking about modify your protein, improve the functionality, you also have to balance the cost, right? If you increase the cost and make end user margin is really low, it costs more to switch the protein because it takes years, it takes time, it takes like industrial scale to validate the shelf life, validate the consumer feedback, and then switch this saving 50 cents maybe not doesn't make that much sense for a finished product developer. So regulatory, as mentioned, is quite important, especially for this novel food ingredients. In Europe, we have to like really spend a lot of time in trying to justify or qualify a new ingredient for Europe to be qualified for a novel food. Okay, this slide is quite straightforward to compare the proteins. So for soy pea almond, if you look at the first line, which is PCAS, you can name it. So based on the calculation, so based on the WHO, the FAO standard for calculation, this number may be different. So you don't have to remember the absolute number here. Based on different age group, this number will be different. Vendors will be different. So the idea is to show what the industry want. What will be good for consumer is to have a very good PDCAS1 protein source. Means you have all the BCAA, you have all the amino acid score to be as high as possible. And also you want it to be a complete protein, so that's also kind of related to the PCAS. And flavor aroma, so you don't want to have your protein to taste very beany, astringent, or some of the protein even taste like a little bit sweet. Some of them very have like a very mouthfeel is very coarse, like it's we'll see it, you inst like chickpea, you can feel in your tongue. And also the solubility. So most of plant protein has a limited solubility. So the industry is working on it to further improve it. And also the allergen, as Professor Zhao has screening for the allergen risk across the new diverse protein, you also have to consider. So actually a lot of authority is considering some new protein to be have an allergen risk. So beside the top eight, they are trying to evaluate that there is no allergen risk. So using Professor Zhao's tool could be super helpful. Functionality. Functionality, as I mentioned, you have to think about what specific functionality of this protein. Like for the beverage, you want to have a mouthfeel. You want to have a good solubility and creamy mouthfeel as a dairy alternative as milk. However, when you formulate a 30 grams RTD beverage or nutrition supplements, you do not want to have a higher viscosity. You want to keep the particles still suspended in the solution without precipitate out to have a gelling effect or aggregates format, which limited your shelf life. And also you want to have a clean label. So a lot of vendor provide clean label as their ingredient. Could be USDA organic. It could be non-allergen. It could be like upper upcycled. So it could be all the new clean label you can put in your package. I just mentioned. So the last point I want to mention is the consumer. So I think I'm a little bit over time. I'll go through this really quick. So last year under Nestle Health Science, we have launched this brand under Orgain. It's called Better Way. So it's using precision fermented proteins, means like non the whey protein not from cow. We have claimed to communicate with consumer how good this protein, how clean protein, high in BCAA, branching amino acid, how good is sustainability, lactose free. So on top of it, the best and most promising convey the knowledge is the lactose free. So if you put a lot of health benefit in your label, consumers may only pick the one more close to them. They won't, as I mentioned, they won't pay extra dollars because it's more sustainable, will make the earth better. Unfortunately, that's the reality of US market. I'm not familiar with EU because Europe, I think they put a higher volume value in terms when they pursue the product. They pay more attention in terms of carbon footprint. However, in US, this scenario is not mature now. And the second one for the market strategy, a lot of product they are big player. They have like strategy partnership with different type of markets. And also big vendors, they become like a friend together, of course, joint venture, and they become one company, and they are using precision fermentation technology, work on new ingredients. So I would say like those marketing is super, super important for the industry to know that the different expertise area company, they partnership together, trying to reduce the risk and use their expertise, combine their fermentation and end user together to mitigate the risk. And regulation, as I mentioned, EFSA is so challenging. FDA, a lot of product already approved have a GRAS. If you're familiar with terminology, we call GRAS, GRAS approved, self-affirmed GRAS. Those are regulatory requirements for ingredient to be commercially available to pass the regulatory approval in US. So I'll stop here in a nutshell. I want to invite everyone to embrace the opportunity for alternative proteins. So we will have using alternative protein to addressing the challenge and using technology to embrace the opportunity. And also we want to effectively communicate and put a good marketing positioning in order to have a success for a launch for the market. So thank you. Thank you for everyone. Bear with me for the 32 minutes. And hopefully we will retire the cow and brew our future with alternative protein. Thank you. Happy to take any questions.
Yeah, thank you, Dr. Shi, for like this great presentation and made us know a lot of those valuable insights from industry and the consumer side. So we did